Dear students, today we will discuss on some points. The first point is heat of combustion. A standard heat of combustion. Suppose we have methane molecule along with its burn along with oxygen. You will obtain CO2 plus H2O. The quantity taken of methane will be 1 mole. 1 mole quantity of ethane can be calculated as carbon has the atomic weight is 12 and for hydrogen atomic weight is 4 plus 1. Therefore totally you will obtain the 16. If you attach to this gram, then this quantity is a 1 mole quantity of methane. Okay, you take the 1 mole quantity, this, and burn with oxygen, air oxygen, or with the heat is change in heat in this process is nothing but the standard heat of combustion. And you remember that when you consider the standard means there is a standard state. Which are this standard state? The standard states are the 298 degree Kelvin temperature and your atmospheric pressure will be 1. This you have to maintain, and this total methane molecule you have to burn 1 mole of methane molecule. Totally the change in heat is called as the standard heat of combustion, and you have to maintain the standard states. Okay, how we define the standard heat of combustion? The amount of heat changes when 1 mole of substance completely burn gives at standard state. Okay, the standard state are 298 Kelvin degree Celsius temperature and 1 atmospheric pressure. It's called, gives a product called the heat of combustion. Heat of combustion. Okay, and the temperature you maintain 298 degree Kelvin. What it implies? It implies you have maintained the temperature of reactant and product 298 degree Kelvin. After during the burning, temperature definitely increases, but we maintain the 298 degree Kelvin. Okay. The energy is released in this process, and heat of combustion is given as delta Hc, delta naught Hc 890.1 kilojoule energy will be released. If energy is releases, we give the negative sign. Okay, negative sign for the heat will evolve or reaction is the exothermic, then we will give the negative sign for this energy. Okay, in this is delta is stand for the change, that is enthalpy, and is a C for the combustion. This is all about the standard heat of combustion. 1 mole of substance totally burnt at a standard condition. This will give the produces the heat, and this kind of heat is called as the standard heat of combustion. Now the second point we will discuss here is standard heat of neutralization. Okay, or heat of neutralization. Heat of neutralization. Okay, neutralization. You hear this term anywhere, neutralization. When acid and base mix together, they will neutralize. They produces salt and water. This process is nothing but the neutralization process. Okay, therefore what is the neutralization? If you have the base plus you add the acid, you will get the H2O and NaCl. NaCl is the salt. NaCl plus H2O. Okay, Na has the plus and minus charge. Okay, the charge containing pieces are the salt pieces. Remember that. And it dissolves salt readily dissolve in water. Remember that. Okay, this reaction is your neutralization reaction. This happens with base and acid mixed together, then neutralization reaction will be happen. Now, what is meaning of heat of neutralization? Firstly, heat of neutralization, which acid and bases give the heat of neutralization, which is having the hydrogen and the OH containing moiety. These acids and bases give the heat of neutralization. In heat of neutralization, definitely salt and water will be produced. Suppose you have taken 1 gram equivalent NaOH and you also taken 1 gram equivalent HCl. The 1 gram equivalent quantity means what? 1 gram equivalent quantity means its equivalent weight. It means its equivalent weight. For bases and acids, we can calculate it as its equivalent weight. The formula is equivalent weight for acid. Okay, suppose you have NaOH is equal to molecular weight upon its basicity. If acid is there, you remember that at the bottom there should be the basicity, molecular weight upon basicity for the acid, and for the base equivalent weight is equal to molecular weight upon its acidity for the base. Okay, for NaOH molecular weight or mole. Okay, instead of this you can also take the mole. How we calculate the molecular weight of NaOH? Na has the 23 atomic weight plus oxygen 16 plus hydrogen 1. Okay, oxygen has this molecular weight 16. Total, the 40 is its molecular weight. And then acidity of this base will be defined as number of OH gives the acidity. If OH in twice in quantity, then acidity will be 2. For H2SO4, you found that its weight is the 98, molecular weight is 98. What is its Basicity for H2SO4, basicity of H2SO4 is total number of hydrogen, which total number of H plus hydrogen or total number of H2. Total number of hydrogen in acid is nothing but your basicity. Remember, for acid you consider the basicity. Number of OH in base is nothing but its acidity. If number of OH is thrice, so for example Ca OH twice, in Ca OH twice, OH is its acidity. For HNO3 only one H is there, its basicity is 1. Okay, like that. Therefore for NaOH it's 40, its molecular weight upon its basicity is 1. Therefore 40 gram is your 1 gram equivalent weight. Okay, for HCl we found that total 36.5 total weight for hydrogen 1 and chlorine 35.5. Then acidity is 1 for HCl. Okay, we use the for acidity, for this is for base, and for acidity it is 36.5 is our this quantity. Okay, this is about the mole and the 1 gram equivalent quantity. What is meaning of 1 gram equivalent quantity? Okay, we clear that. You take the 1 gram equivalent quantity both and mix together. Heat is produced. Okay, that heat produced is nothing but the heat is produced is 57.1 kilojoule heat is produced when these two mix. Both are, this is the strong acid and the strong base. Strong acid and strong base concept means what? The acid which dissociates completely is called as the strong acid. For example, in HCl you have the 100 HCl is there. Total 100 H plus is dissociate into its ion. Therefore, totally dissociation means what? Dissociation means break. Break means the not totally break. It's in solution. It's separate. Totally separation. Not breaks. Separation. Therefore, dissociation of H plus totally is happen. Then it is a strong acid. It both are the strong base and strong base. Dissociation of all these quantities will be 100%. Okay, now if you have the acetic acid, it dissociation in less quantity, and therefore it is a weak acid. If suppose it has the 100 molecule, it's only 10 molecule dissociate. Only give that H plus 10 and CH3O minus 10 and remaining quantity as it is CH3COH. Okay, totally not dissociate. Okay, only some quantity is dissociate. Only some molecule will dissociate. Okay, for the sake of convenience, we take the 10. Okay, 100 amongst the 100, only 10 will be dissociated. Very small dissociation is very separation of the ions is very less. That's why that acids and bases is called as the weak acids and bases. Okay, how we now define the heat of neutralization? The amount of heat changed or takes place when 1 gram equivalent. Okay, gram equivalent means what? We have previously discussed. Gram equivalent of acid and bases neutralizes, gives salt and water. Okay, during this process some heat is the will exothermic reaction. This is the exothermic, some heat is the given to the surrounding, and that heat is called as the heat of neutralization. It is term is related to the acid and bases. For strong acids, okay, you remember only these acids. Okay, in laboratory you have known the HCl, HNO3, then H2SO4. All these acids are the strong acids. Remember, strong acids. NaOH is a strong acid, strong base, and KOH is a strong base. Okay, strong means, you remember the word, if you said there is a strong, it means it dissociate completely. If it is weak, it means it dissociate in less quantity. It solid in less quantity. It gives the ions in solution in less quantity. Okay, that's strong and weak. The word when we came, then we thought that the strong is the strong dissociation, weak means the weak dissociation. Weak means the less dissociation, strong means the higher dissociation or completely dissociation. When you measure, the heat of neutralization, strong acid and strong base, okay, these are strong acid and strong base, always will be 57.1. Always, if you change the acids, if you, for example, you use the HNO3 and KOH, it gives your H2O and KNO3 salt. In this case also there is the 57.1 kilojoule heat of neutralization there. Therefore, if there is a strong acid and strong base, then heat of neutralization is always 57.1 kilojoule. Why this is happened? Because always in each case of neutralization you take the 1 gram equivalent, 1 gram equivalent. 1 gram equivalent means, if you show like that, H plus NO3 minus plus K plus OH minus, okay, dissociation is there, okay, like that, and it will obtain like that, K plus NO3 minus plus H plus, or you said the H2O. Okay, therefore the quantity of is its gram equivalent weight is 1 and gram equivalent weight is, so oxygen is 16, hydrogen is 1, therefore gram equivalent weight is the 17 gram. Okay, 1 and 17 gram is 18 gram. Always you obtain the 18 gram H2O, 1 equivalent weight of H2O always. If for example, if you change HNO3, HCl plus this example, okay, this will be cancelled. Therefore the term remaining is the H and OH always the time. Okay, therefore you take the Na plus OH minus, then it will give the H plus Cl minus, it give the Na plus Cl minus plus H2. Okay, at this case also NaNH Cl minus is cancelled. It's equivalent to 7. 1 it always give the 8 gram of NaOH when 1 gram equivalent weight you use. Therefore, when the strong acid and strong base is there, it always give the 57.1 kilojoule heat of neutralization. Now, for weak acids or weak base, the heat of neutralization always less than 57.1 kilojoule. It's not gives the constant quantity. Suppose we have CH3 COH, acetic acid, plus NaOH. Okay, this is also the heat of neutralization, because it has H, it has the OH, both are the neutralized. You will obtain salt CH3CO Na. Okay, this Na and this will get together, CH3CO Na, and this OH and H, H2O, obtain the H2O. In this case, this is a weak acid. This is the weak acid. Weak acid means it only gives the small dissociations. For example, it is having the 100, you will obtain only 10 CH3 CONA you obtain, plus H2O is also 10 is obtained, and remaining quantity is as it is. Okay, therefore when 10 molecule is the neutralizes, same energy is produces. Okay, and this energy produces will further used for dissociation of CH3CON. Okay, because it is very weak, therefore for dissociation of all, at the last, okay, CH3 is there, at the last, okay, 90 molecule is there, at the last the energy, some energy will be used for dissociation of acetic acid, CH3CO minus, plus that H plus is obtained there. Okay, it is a CH3COH. Remaining molecule will be dissociated by using the heat produced by this 10 molecule. Okay, some heat will be lasted in dissociation of this molecule. Therefore, heat is lost at some heat 57 point is obtained something about less than 57. You will obtain the value less than 57 kilojoule for the heat of neutralization. Weak acid and strong base, any weak, if there is weak, acid is weak, base is strong, or base is weak, acid is weak, such condition is arises. Total dissociation will be happen when heat of neutralization, and that energy is used for the total dissociation. Therefore, when you have the weak acids or weak base, the heat of neutralization always less than this quantity. Okay, this is all about the heat of neutralization. Now we will discuss the heat of fusion, then heat of vaporization, and heat of sublimation. Okay, suppose for heat of fusion you have ice water is there and gives you the liquid. Okay, then sorry, before we will discuss the heat of vaporization, then we will discuss heat of fusion. Heat of vaporization, suppose we have the H2O, it gives the H2O, but H2 is the liquid, it gives the H2O in gas form or in steam form. Okay, you use the 1 mole of H2O. 1 mole of H2O, how many quantity? H2 is twice quantity, 2. Oxygen 1 quantity, 16. 18 gram is your H2 is the 1 mole. Okay, quantity you have to take on the 1 mole for measuring the heat of vaporization. Okay, then 1 mole of liquid you used and it vaporizes at its boiling point. Remember, you have to boil it. It vaporizes at its boiling points. The heat, change in heat, when 1 mole of liquid is converted into its gas form at its boiling point, is called as heat of vaporization. Okay, something value will be there, heat of vaporization. Liquid is converted into vapor form. Okay, remember that. That is the related. That is the relation. Heat, liquid converted into the gas. That is nothing but the heat of vaporization. What we discuss, 1 mole you required liquid, that particular any liquid, and which will convert into gas form at its boiling point. The energy is there will be considered as the heat of vaporization. Heat of sublimation means what? Sublimation means what? Sublimation is your solid is dielectrically converted into vapor phase, is called as the sublimation. Suppose you have the camphor. Okay, in your home there is camphor, is directly converted into the vapor phase at the room temperature also. Suppose you have the naphthalene, anthracene, all these at room temperature directly converted into vapor phase without melting. Without melting, it directly converted into vapor phase. Therefore, you have the, if suppose you have the naphthalene is there, 1 mole of naphthalene will be converted into vapor phase. Okay, directly vapor naphthalene. But you have to maintain the temperature less than its melting points, because when you give the temperature at its melting points, it will melt. That is nothing but the sublimation. Sublimation is a process your solid is directly converted into vapor phase and the temperature you given is less than its melting point. That is the heat of sublimation. The solid substance is directly converted into vapor phase. That process is the heat of sublimation. Okay, the quantity heat change is when 1 mole of substance is completely sublimated into 1 mole of its gaseous form or vapor form and below its melting points. Okay, this is the values of delta we have here. The values of delta will be the, for the heat of vaporization, values of delta will be the 40.7 kilojoule. For these values will be the 62.39 kilojoule. Okay, this is all about the this. And heat of fusion means the heat change takes place when 1 mole of solid substance changes into its liquid substance. That is the heat of fusion. Okay, previously we said one fusion means if you have the H2O, ice form is converted into liquid form. Okay, during this process the change in heat. Okay, for remember that we always take the 1 mole of H2O. 1 mole of H2O is the 18 gram. You take the H2O and total H2O 18 gram ice will be converted into liquid form. The delta H fusion is equal to the round about 6 kilojoule. Ice is totally converted, 1 mole of ice totally converted into liquid. The change in heat takes place. That heat is nothing but our heat of fusion. This is all about the today we have discussed. Thank you very much carefully listening this.